Okay, now that you've done a short lab, kind of introducing you to the concept of a mole, we are going to do some on-paper practice. Okay, so you've had your hands on particles and looking at how we measure how much each particle weighs. We do the same thing with atoms. Somebody's done a lot of the hard work for us already and put it into the periodic table as the atomic mass. So if you remember, atomic mass is equal to protons plus neutrons. Right? Okay. And so we're actually looking at the mass of those things. Mass can be measured in this case as grams per mole. As we go through this activity, please feel free to pause at the end of each section and work the rest of the problems in that section on your own. Don't forget to show all of your work. That's how you're going to get credit for this. I'm not going to be looking at the answers. I'm going to be looking at, did you show me your work and how you got there? Okay. The first section is actually pretty easy. So we're looking at the molar mass for the following elements. The molar mass is a really fancy name for AMU. Remember, a long time way back, we talked about AMU, or the atomic mass units. If we're looking at our periodic table, that is the atomic mass, okay? So I'm going to start with my first element. I know that Cu is copper, and if I don't know that, it's okay, because I have my periodic table. So I'm going to go to my periodic table. Hopefully it will load. There we go. Okay, and I'm going to find copper on my periodic table. It's right here, element number 29. I know that that means that it has 29 protons, and I also can look at the bottom number. So I'm looking right here. I have 63.546. That is my atomic mass unit for copper, okay, or my AMU, which we can also represent as grams per mole. Oh, I'm going to look at that number again. So I have 63.546. So for copper, my atomic mass is 63.546 AMU. I get that from my periodic table. Okay, and then I don't have to do anything. I am just representing this in units that I will then be using later to convert into mole, help me out with mole conversions. Okay, so I've got this in grams per mole. And that tells me that I have, for copper, for every 6.022 times 10 to the 24th, which is Avogadro's number, or the 23rd, excuse me, which is Avogadro's number, atoms of copper, it's going to weigh 63.546 grams. Okay? So now it's your turn. Go to your periodic table, find the atomic mass for each of the other elements: helium, nitrogen, fluorine, silver, and radon. Go ahead and pause the video. Once you've completed that section, you can start the video back up for the next section. Okay, now we're going to be determining the mass of the following molar samples. Okay, all that this means is now we're looking at, okay, we know how much it weighs because we can find that on the periodic table. And then I'm going to multiply that by the number of moles that we have. So for our first one, for copper, we already know from our last problem and from looking at our periodic table that copper's atomic mass is 63.546 grams per mole. So I'm going to go ahead and write that out right here, 63.546 grams per every 1 mole. Okay, and this is telling us that we have 2 moles of copper, and we're trying to determine the mass, which tells me that I want my final unit to be in grams, because that's how we measure mass, right? Okay, so if I'm trying to get to grams as my final mass unit, and I have grams over mole, remember that I need to multiply by moles to get rid of that unit. Okay, this is just going to be over 1. We don't need any units at the bottom. We're already canceling out moles. And my problem tells me that I have 2 moles. So I'm going to then multiply across the top and multiply across the bottom. I can cancel out my moles because we have 1 on the top and the bottom. And then my total number of grams is going to be 63.546 times 2. So I'm going to pull out my handy dandy calculator over here, and I'm going to multiply 63.546 grams times 2 to get 127.092 grams. Okay, because this is an exact number, if I'm looking for significant figures, I can follow my sig fig rules for this first number. This 2 moles is an exact number, so it would be 2.00000000000 out forever. Okay, so we use the first number to determine our significant figures. In this case, we have 5 significant figures. So when I get to my answer, because I'm multiplying, I would want to round this to 127.09 grams so that I have 5 significant figures like I started out with. Okay. All right, now it's your turn. Follow the same steps for each of the following problems to determine how many grams of each substance you have. Pause the video and start it back up when you finish this section. All right, now you've successfully figured out the mass. This time we're going to go the other direction. Now we're trying to figure out how many moles of a particular substance we have, okay? So we're going to use dimensional analysis again. This time we are looking at, okay, we have the grams. We know how many grams per mole there are using the periodic table. So we're just going to follow the same process. This time we want to have our final number be, or our final unit, excuse me, be moles. Okay, so here we go. We have 54.2 grams. That's just going to be over 1 because there's nothing else in that unit for us to use. Okay, I want to get to moles at the end. So I know that I'm going to need to cancel out grams. So I need grams on the bottom and then moles on the top. Okay, I'm going to look on the periodic table to find my AMU, or grams per mole of oxygen. So oxygen is number 8 right here. It is 15.999. I'm going to go ahead and just round that up to 16.0 because it's very close. And that oxygen has an AMU of 16.0 grams per mole. Okay, now notice that my grams are on the top, my mole is on the bottom when I take that from the periodic table. If I look at how I need to do this for dimensional analysis, I need my grams on the bottom and my mole on the top. Okay, so you're just flip-flopping those units, taking the numbers with you. So 16 grams for every 1 mole. Okay, and remember, this is a dimensional analysis, so that unit is 1 mole equals the exact same thing as 16 grams. So it doesn't matter which side of the numerator or denominator I have it on because it equals 1. All right, so I'm canceling out my grams. That leaves me with moles, and then I'm going to do the math. 54.2 times 1 on the top, 1 times 16 on the bottom, so I can just simply divide 54.2 by 16. Pull up my calculator, and I'm going to do that. 54.2 divided by 16. My final answer is going to be 3.3875 moles. And then I'm going to look at my significant figures, which we have 3 in both of these cases. So we want to round our final answer to the appropriate number of significant figures, which in this case is 3 significant figures. So I'm going to do 3.39 moles, rounding up to having 3 significant figures for my answer. Okay. Follow the same steps to do the rest of the problems. Pause the video and come back when you're finished. Okay, now we are getting into, I'm not going to say tougher stuff, we're just building on what we've already looked at. Okay, so now we're going to be determining the molar mass for a molecule or compound. Okay, this time we are going to have to take multiple masses in order to do the math for this. Okay, so I'm looking at calcium plus chloride, and in this case 2 chlorides. What am I going to have? Okay, so For every molecule, I'm going to have 1 calcium, because there's no subscript next to that, and I'm going to have 2 chlorides, okay? So the first thing you've got to do is pull out what are you going to have of each one. Okay, set that up. Now I'm looking at the molar mass. So again, I'm looking for my grams per mole, or my AMU, my atomic mass unit, for a mole of the compound, okay? So to do this, I'm simply going to multiply the molar mass that I find on my periodic table by the number of atoms of that particular element that there are in the compound. Okay, so in this first one, I have 1 calcium atom and 2 chloride atoms. So I'm going to multiply the atomic mass of calcium, go to my periodic table and find it. It is 40.078. 0.78, there we go, plus 2 times whatever the grams of calcium, the mass of calcium is. Calcium, or not calcium, I'm sorry, chlorine is what I'm looking for. There we go. So chlorine is 35.45 grams per mole. Oops, and I forgot my units. I need to write that in there. This one also will have grams per mole. Okay, let me just erase that, make it a little cleaner so we can all tell what that says. Grams per mole. Okay, and then I'm just doing the math. Okay, my final unit is going to be grams per mole. So I'm multiplying 1 times 40.078 grams per mole, and that will get added to 2 times 35.45. Pull out my handy dandy calculator. 2 times 35.45, which is going to equal 70.9 grams per mole. And then I'm adding those 2 numbers up to get my final total of the mass, the molar mass of a single mole of this compound. So that would be 110.978 grams per mole. Okay, if we need to get this into the appropriate number of significant figures, notice that we started out here with 4, we started out here with 5, and so when we multiplied, we ended up with 3. This, because we're adding, we're looking at place value. So I have thousandths, and then tens right here. Tens is less precise than thousandths, and so we need to use that tens place when we're adding up. So I'm going to be going to this tenths place value here. If I'm looking at significant figures, so this would be 100 point. Actually, I have to round up, so this would actually be 111.0 grams per mole. That would be my final answer for the molar mass of calcium chloride, which has 1 atom of calcium and 2 atoms of chloride for every molecule. Okay. All right, your turn. Follow these steps. Substitute in your masses beside the number, however many you have, and go back through that on your own for these next 5 problems. Pause the video and come back when you're done for the next section. Okay, last but definitely not least, actually not last, we'll do last in a few minutes. We're going to figure out how many particles of something that we have. So now we're looking at, for the first one, oxygen. How many atoms of oxygen do we have in 54.2 grams? Okay, this is going to become very important because when we start reacting things together, we're going to need to know how many atoms are going to combine with each other to figure out what's going to happen in our reactions. Okay, so 54.2 grams of oxygen. Now, I remember at the top of, or at the bottom of my first page, we calculated the number of moles. So I already know how many moles there are in oxygen. I'm going to use that number and Avogadro's number to help me figure out how many atoms I have. If you'll remember, moles is the number of particles in every 6.022 times 10 to the 23rd. That's how many particles there are in every mole. Just like there are 12 of something in a dozen, okay? A mole is 6.022 times 10 to the 23rd, okay? And so we're going to use that knowledge to help us figure out how many atoms we have, okay? We've already determined using our periodic table that oxygen has an atomic mass of 16.0 grams per mole. And using that, we figured out that in 54.2 grams of oxygen, there are 3.39 moles. Okay, so we've already done that part of it. Now we're going to come back down here. We have 3.39 moles. Okay, and remember that in every mole, we have Avogadro's number of particles, or atoms in this case, because we only have one oxygen. Okay, so I have 6.022 times 10 to the 23rd atoms or particles. It doesn't really matter which term you use in this case, okay, for every 1 mole of any given substance. Okay, in this case, we're looking at oxygen. My moles will then cancel out, and my final answer is going to be in atoms because I could cancel out my moles. Okay, so I'm going to multiply 3.39 times 6.022 times 10 to the 23rd. Get out my handy-dandy calculator because there's no way I'm doing that in my head. 3.39 times 6.022 times 10 to the, pull up my scientific version, to the 23rd. Don't forget, if you're doing this on a calculator, it's not actually a scientific one, to put your parentheses around the 6.022 times 10 to the 23rd. I'll show you what it looks like on my screen. If you don't put your parentheses there, then it's not going to recognize that it's a whole number, and sometimes it can cause errors in calculation, okay? And that is going to give me 2.04 blah, 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 times 10 to the 24th. Because I started out with only 3 significant figures here, that is what my answer is going to be in, is 3 significant figures. Okay, so I have 2.04 times 10 to the 24th atoms. And that is my final answer. Okay, if you need to zoom in or move your work around so that it can fit under, I know I went underneath calcium, then feel free to do your work in whatever order you want to. This seemed the cleanest for me while I was explaining it to you. Okay, go ahead and pause the video and use this information to help you complete the remainder of the problems in this section. Unpause when you're ready to move to the next section. Okay, we've officially graduated. This time I'm going to do the middle one because we're going to be doing multiple steps, combining all these steps that we've done together into one cohesive idea, okay? So when I go to do a chemical reaction, I'm going to need to know how many atoms of carbon dioxide I start out with in this chemical reaction that I'm doing, okay? And it tells me, I weigh it out, I have 65 grams of it, okay? So I need to figure out how many atoms do I have. This is where our dimensional analysis really comes into play. I'm starting out with 65 grams of CO2. Okay, I know that I need to get at the end to the number of atoms, right? Determine how many atoms or molecules are in the sample. Okay, so I need to set this up so that I can get to atoms. I know that I can determine how many grams per mole there are of CO2 using the same method that we used in this section right here, where I add up and figure out my total molar mass for the particular molecule. Okay, so because I know my grams per mole, I can cancel out my grams here using grams per mole. And then to get to atoms, just like we did in this problem, I need to cancel out my moles and use Avogadro's constant to let me get to atoms. So I'm going to cancel out moles by putting it on the bottom, and then I'm going to use Avogadro's constant here, times 10 to the 23rd. or molecules in this case, because CO2 is a molecule, not an atom. Okay, and so I'm set up now to be able to cancel out my grams, cancel out my moles, and end up in atoms. Now I need to plug the numbers to plug in. For carbon dioxide, I have 1 carbon and 2 oxygens. So I'm going to go to my periodic table and say, okay, carbon has a molar mass of 12.011. 12.011. I know that that's in grams per mole. And if I add that to the oxygen's mass, I'll have the total for CO2. So oxygen is 15.999, which again, I'm going to round up to 16.0. You have my permission to do that anytime you run into oxygen in your calculations, okay? And so now I'm going to multiply 1 times 12.011, which is going to be 12.011 grams per mole, and I'm going to multiply 16 times 2. If you need to, pull out your calculator. A lot of you can actually do this in your head, okay? So 16 times 2 is going to equal 32.0 grams per mole. And then when I add those two things together, my 32 plus 12.011, I'm going to get 44.011 grams per mole, okay? That is how many grams per mole there are in carbon dioxide, okay? So now that I know my grams per mole, I'm going to use that amount and plug it in up here so that I can get my final answer. So I have 44.011 grams for every 1 mole of carbon dioxide. And then I know that for every 1 mole of any substance, there are 6.022 times 10 to the 23rd molecules. And I'm going to erase atoms because in this particular case, we are looking at molecules and not atoms. Now I'm just going to do the math. I'm going to multiply across the top, multiply across the bottom, and divide. So here we go. 65 times, parentheses, 6.022 times 10 to the 23rd, end parentheses. So that's going to give me my top, my numerator. And then I'm going to divide that number by 44.011 because that is my bottom number. And my final answer is going to be 8.89. Oh, I need 1 fewer significant figure because 65 started out with only 2 significant figures. When I'm multiplying and dividing, I have to use the least number of significant figures. Okay, so I need to round this up to 8.9 times 10 to the 23rd molecules. And that is my final answer. Okay, so we've put all of our pieces together. It is your turn. I recommend that you start out right here with silicon because you're only going to be using 1 atom to do it, and then work your way up here to silver chloride next. If you need some additional help or some additional practice problems for this, just let your instructor know. Good luck. Thank you for working through this video. Again, don't forget to show your work on your paper for credit and let your instructor know if you have any questions or concerns.